Okay, welcome back. This is Mr. Hassan's Maths channel, and this is a question I've been asked from the P1 International A-Level Pure Mathematics textbook from Pearson's at Excel. And this question here is from exercise 2B from chapter 2 of quadratics. It's about a trapezium which has an area of 50 meters squared. So the area of the trapezium is 50 meters squared. And there we have to show that the height of the trapezium is equal to 5 times root 5 minus 1 meters. The trapezium has a height of 2x. In terms of x is 2x. The width, that's the distance between the parallel sides of the trapezium, and you've got the length of the two parallel sides are x meters and x plus 10 meters. So first of all, the area of a trapezium is given by a formula, which basically tells you that the distance between the parallel sides, which we're going to call it h, divided by 2, half the distance between the parallel sides times the sum of the lengths of the parallel sides gives you the area. Some people memorize it as like a half times a plus b times h, whatever. I just like to think of it like this: the distance between the parallel sides divided by 2 times the sum of the parallel sides is the area of the trapezium. Okay, now what we want to do here is we want to equate these two together. We know that the height of the trapezium is given by 2x. So that's 2x divided by 2 times the sum of the parallel sides, which is x plus 10. That's the area of the trapezium in terms of the lengths given in terms of x, and that's equal to 50. So the 2 cancels with the 2. You have x times, and inside here you're going to have 2x plus 10 equals 50. Now what we could do is we could expand this bracket here, so we have 2x squared plus 10x, and we can subtract 50 from both sides, so we're left with like this quadratic looking thing here. To make life easy, we can divide both sides by 2. So you have x squared plus 5x minus 25 equals 0. And now what we can do is we can try to solve this. Now this won't factorize. We know it won't factorize because of the way that the answer is going to look. You say 5 times the square root of root 5 minus, 5 times root 5 minus 1. So of course you're going to end up with the irrational answer. So this is not going to factorize. No bother trying to factorize. We can use the formula. We can complete the square. Okay, the formula is pretty much just putting values into a given formula, which I'm going to show you how to do it using completing the square. To practice completing the square, which is an important skill, which we're going to use for other things apart from just solving equations. So it's good for us to be very familiar with it. So I'm going to use completing the square to solve this. So I'm going to add first 25 to both sides, because when I complete the square to solve a quadratic equation, I like to always isolate the x squared and x terms together on their own. Okay, I like to focus on those two when I complete the square and not really think about the other term. So now what I'm going to do is I'm going to complete the square for this. So this is x plus, now you take a half of the coefficient of 5, which is 5 over 2, squared, and then you're going to take away the square of this number. Now the reason why we do that is because when we expand this bracket, we're going to have x squared plus 5 over 2x plus another 5 over 2x, which is 5x. And then we're going to have plus 25 over 4. Now we don't want that 25 over 4. It's not there. So we've got to take it away. So this now becomes the same as x squared plus 5x. But the difference is now we have a bracket that's squared, which will make it easy for us to solve equations now. So now what I can do is I can add 25 over 4 to both sides to get to isolate the squared bracket on its own on one side of the equation. So I've got to 25 plus 25 over 4. So 25, if I want to make it over 4, it's going to be like 100 over 4. Okay, if I multiply this 25 over 1, multiply by 4, I get 100 over 4. That's plus 125 over 4. Okay, so, sorry, not 125, plus 25 over 4. I'm going ahead of myself there. Okay, and so now I have x plus 5 over 2 squared equals 125 over 4. So I just added 25 plus 25 over 4, which gave me 125 over 4. Now I can take the square root of both sides. Now, don't forget to take the positive and negative square root of both sides first, and then we can see what we can do with those answers. So we're going to have plus or minus the square root of 125 over 2. The square root of 4 gives you an exact value 2. So we're left with here, now root of 125 over 2 is going to give us, basically 5 times 25. So you have 25 times 5 is 125. So this is going to be 5 root 5. So you have x plus 5 over 2 equals plus or minus 5 times root 5 divided by 2. So your answer for x is going to be minus 5 plus or minus 5 times root 5 over 2. All right, now we know that the lengths cannot be negative, so the length has to be positive only. So we can say, therefore, our x must be minus 5 plus 5 root 5 over 2. Okay, minus 5 plus 5 root 5 over 2. Okay, that must be the length. Because minus 5 minus 5 root 5 over 2 is going to be negative. So we can say, therefore, the height of the trapezium. Now remember, you see, the problem is, a lot of people, they don't read the question properly. The question says, find the height of the trapezium. It doesn't say find x. X is not the height of the trapezium. Okay, x is, this length here. The height in terms of x is 2x. So what we have to do is you have to multiply this answer by 2. So you have the height is equal to 2 times minus 5 plus root 5 over 2 plus 5 root 5 over 2, sorry. The 2's cancel out, so you're left with basically minus 5 plus 5 root 5. Okay, now they want it in this form here, which has got factorized 5 times root 5 minus 1. So what we can do here is you can say this is like 5 times root 5 minus 5, and then take out 5 as common. So you have root 5 minus 1 inside. And there we have the height of the trapezium in the form that they want it. Okay, so there's the answer. Now remember, reject, as they gave us a clue here, we only want the positive solution, not the negative solution, because in this context, the negative solution doesn't make sense. You can't have a negative length. So the height of this trapezium is 5 root 5 minus 1, 5 times bracket root 5 minus 1, as they asked for. Okay, so that's how you deal with this question. Student who asked this question, hope that you understood it. Other questions about or on this, from this particular chapter of the P1 book, can be found in the playlist that should be found in this area here. Other questions from quadratics of P2 can be found over here in general. Thank you for watching, and see you soon.